Well, hey everybody. We're talking about independence. I don't think I did the best job explaining it in class today, so we're gonna really hit it hard here. At least in fourth. Anyhow, so there's really two ways I talked about proving independence. The the first way has to do with the multiplication rule. You plug in numbers to this rule, and if it balances out, like if the right side equals the left side, you know they're independent. If it don't balance out, then you know they're not independent. So the example we gave in class um, was a dice, a heads and tails one. So I'll do a simplified version of this. Um, let's just say you flip two coins, and you want to know if those two coin flips are independent. I mean, we know that they are, but like what you can do with this rule is you have to just think. Let's just say you want to get, you're shooting for a heads and a tails. So you want heads and tails. Well, if you can test, so heads first, then tails. So if you can test that the probability of a heads times the probability of a tails, if the tails on the second throw, if that straight up equals the probability of heads and tails, you're good. So, I mean, all possible outcomes are heads, 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 tails, tails, heads, tails, tails, right? So we kind of can look at it like this. You just basically you see, okay, what's the probability of tails on the second throw? Well, that's those two. What's the probability of heads on the first throw? Well, that's those two. So it's 1/2 and 1/2, or 0.5, 0.5. So if that equals the probability of getting a heads and a tails when you multiply those two together, then they're independent. If they don't equal, they're not independent. So you can do this for any. If you have the and, you have one, and you have the other, you can make this test happen. So heads and tails only occurs under one circumstance, and that's this one. Heads, because we were talking about in order, right? So heads first, then tails. Obviously that's tails, heads, but we're talking about first throw, second throw. So then we got 0.25. So if 0.5 times 0.5 equals 0.25, they're independent. And it does, so you know they're independent. An easier one to explain is actually the second rule. The hardest part about the second rule is getting the given section, but the way to explain this is if the probability of A is the same as the probability of A given B already happened, then they're independent. And the reason this makes sense is this means B didn't actually mess with A, right? So if the probability of A just stays the same if B happened, cool, then they're independent. If A was changed because B already happened, well, that's literally the definition of dependent, right? So an example in real life of this would be like, okay, probability of me eating pizza tonight is 0.2. It's my birthday, so it might happen. The probability I eat pizza tonight, given I make a YouTube video, which I'm doing, still 0.2. So in this case, did the YouTube video really change the pizza? No. YouTube video did not affect. And I bet if I was to switch those around, it would still, the probability I make a YouTube video has something to do with the fact if I made pizza tonight? No, that's not going to happen either. So these will be independent. It doesn't matter. This whole thing, this whole given I make a YouTube video, it didn't affect anything. It's still 0.2. Now, that might be different if I use a different two events, like the probability of me eating pizza tonight is 0.2 in general, but what if I decide instead to go out? What if I decide I have a bunch of friends over for a birthday party? Well, maybe having a bunch of friends over is its own event, but if that happens, I'm sure as heck more likely to get pizza. I'm not making food for that many people. So pizza tonight, 0.2. Pizza if I have friends over, 0.5. Did the friends affect the pizza? Heck yeah. I invited them over, and now I'm all of a sudden more likely to eat pizza. That's dependent. So you can kind of see the difference between independent and dependent. Now, the way to actually use this rule is you have to have both of those pieces of information. Sometimes the given part is hard to find. Sometimes it's easy to find. But that is back to conditional probability, which was the lesson before. So if you can't find the given part, that's where you would want to go work on the prior con assignment or look at the conditional probability lesson. But yeah, there we go. Have a good one, everybody.